My understanding is that there isn't really a great translation of the Finnish word Sisu into English, but the idea is perseverance, kind of grittiness.
If you double click on the process that's going on when you're asking a question about why, there's some mental mapping between the metrics the business cares about and a bunch of data that's likely in the cloud somewhere. Provided you can calibrate your classifiers and ensure that you are finding some of those true positives and you're not showing people too much garbage, it's a really, really tractable kind of modeling process.
Peter, welcome to the program. I'm so excited to have you on the Super Data Science Show. Welcome, and where are you calling in from today?
Thanks for having me. Super excited to be here. I am calling in from San Francisco, California.
Nice. Is the weather very San Francisco-y right now?
It's been honestly pretty nice. A little bit of rain.
That's a no.
No. It's been good. It's been good. The sun is shining. It's a beautiful day.
Wonderful. So you are the founder and CEO of Sisu. I love the name of this company. It's a term that I've been exposed to for a while now. My understanding is that there isn't really a great translation of the Finnish word Sisu into English, but the idea is perseverance, kind of grittiness. And I love that in a company name. Why did you choose that for your company?
Yeah, it's a great question. So I'm half Finnish, and when we were spinning out the company, really struggling on what the name should be to kind of capture the ethos and spirit and also be something that's memorable. And it was really struggling to find a name, and went home to visit my parents. And I came back after talking with them about different names, all of which were pretty terrible. My mom was like, "Hey, there's a thing called Sisu that you might be interested in." And there's actually a bunch of stuff that like linguists have done looking at, what is the shape of different words. And, Sisu is kind of an interesting word because you have the C, which is kind of sharp inflection, but then Su is kind of deeper in the throat. So it's bigger. It's almost like this spike, and then it opens up, which I thought was kind of a cool part compared to a bunch of other alternatives that we considered, none of which were particularly good.
I love that. That is a really good explanation. I don't know. I'm really into etymology, so I ask a lot of guests, like, why did you name something this or that? I've never had a guest explain the sounds, like that. This sound is what we were looking for. I love that. All right, so we should talk about what Sisu does, and not just the etymology of the company. So you've been hugely successful in a short period of time. You've raised $62 million in Series C recently, just a couple of months ago, and that brings the total funding raised to $128 million in just 3 years, which is crazy. So congratulations on the rapid growth, and big name venture capital firms are involved. Andreessen Horowitz, DEA, Green Bay Ventures. So what your company does, it's billed as a decision intelligence engine. Peter, what the heck does that mean?
Great question. The idea behind Sisu is really simple. If you think about all of the data that organizations have today, and a lot of the changes have happened in terms of the data stack, Snowflake, cloud warehouses, cheaper ETL, there's this kind of massive amalgamation and consolidation of data inside of a typical organization. But very few people, the end users who have access to data, have any ability to use this data. So you'll have teams staring at dashboards and reports to track their metrics, figuring out what's going on. But as soon as something happens in a metric, or as soon as they need to answer a detailed question, they go ask someone, if they're lucky to have someone to go and ask about, why is this changing? What should we go do about it? And for the analysts and data science teams who are tasked with answering this question on why things are changing and what to go do, it's a huge amount of work. And the reality is there aren't enough people to kind of close what we call this decision gap between the data that's collected and the decisions that can be made. Hence the term decision intelligence. And really what this is taking some of the most painful and repetitive parts of analysis and accelerating them with ML, things like automated feature engineering, feature selection, recommendations to go and help go beyond just kind of what's going on with their data and use all of their data to understand why things are changing, what to go do about it.
Gotcha. So, all right. So I'm going to try to repeat back to you what you've told me with a hypothetical scenario.
Yeah.
All right. So I'm the CEO of a company or I'm the head of analytics of a company, and we get daily reports on how our platform is performing. And we see that today there's a drop in revenue for some particular digital product. It's an unusual drop in revenue, or maybe this unusual jump in revenue. And it might be, so then I could be interested in what the cause is of that change. And today, for the most part, I would, write a Slack message to somebody on my team and say, hey, what's going on today? There's this, really big change in this number. And then that sets off like a cascade of emails and Slacks to other people who are then trying to dig into it. We get the specialist on like this particular area. And then they're getting in touch with other specialists. And so it could end up being a few days, maybe longer, depending on the urgency of the issue, before somebody can come back and kind of explain somewhat definitively what's happened, if at all. And so what you're suggesting is that with your platform, it could automatically somehow come up with some guess as to what the causal factors are.
That's a great summary. I think if you double click on the process that's going on when you're asking a question on why, there's some mental mapping between the metrics the business cares about and a bunch of data that's likely in the cloud somewhere. And if you're Samsung as a customer looking at device upgrades, you've got tons and tons of features about who's upgrading their phones, old phone, old carrier, new carrier, so on. If you're Gusto, which is another kind of public case study, looking at customer satisfaction, you have all the information about who onboarded, what features they're using. And it's not uncommon to have tables or data frames with hundreds, sometimes thousands of different behavioral attributes. And so in some sense, what those people who are responding to Slack messages are doing is effectively doing a lot of feature engineering. They're trying to identify factors that are important. They're trying to assess significance. And then they're going to go and turn into a slide deck to send back to someone. And that process is very repetitive. The metrics are defined by the business like once a year, but the data is always changing. And the kind of insight is that that type of process, which is really only possible now with a lot of the consolidation of data because all the data is in one place and you can have really wide feature vectors, you can start to automate that for more people. And, this can make sure the CEO who asked the question gets their answer back in, 20 minutes as opposed to, 2 days. But it can also enable people who don't have analysts or don't have data science resources to go and answer some of those questions on their own. And the insight's pretty simple. There's a lot of machinery in terms of how you actually make it work well. But if you think about metrics as a concept inside of organizations, defined rarely, updated all the time. And the question is, based on all the context you have around those metrics, what do you want to show to which people at the right time?
Cool. Eliminating unnecessary distractions is one of the central principles of my lifestyle. As such, I only subscribe to a handful of email newsletters, those that provide a massive signal-to-noise ratio. One of the very few that meet my strict criterion is the Data Science Insider. If you weren't aware of it already, the Data Science Insider is a 100% free newsletter that the Super Data Science team creates and sends out every Friday. We pore over all of the news and identify the most important breakthroughs in the fields of data science, machine learning, and artificial intelligence. The top 5, simply 5 news items. The top 5 items are handpicked, the items that we're confident will be most relevant to your personal and professional growth. Each of the 5 articles is summarized into a standardized, easy-to-read format and then packed gently into a single email. This means that you don't have to go and read the whole article. You can read our summary and be up to speed on the latest and greatest data innovations in no time at all. That said, if any items do particularly tickle your fancy, then you can click through and read the full article. This is what I do. I skim the Data Science Insider newsletter every week. Those items that are relevant to me, I read the summary in full. And if that signals to me that I should be digging into the full original piece, for example to pore over figures, equations, code, or experimental methodology, I click through and dig deep. So, if you'd like to get the best signal-to-noise ratio out there in data science, machine learning, and AI news, Subscribe to the Data Science Insider, which is completely free, no strings attached, at superdatascience.com/DSI. That's superdatascience.com/DSI. And now, let's return to our amazing episode. Yeah, that makes a lot of sense. And so that's another case study that I didn't think about there, because I'm kind of thinking about a big organization like Samsung that you mentioned. But in addition, there's all kinds of companies out there, way more. There's a much larger quantity, a much bigger market that I'm sure you've noticed, of smaller companies where you're collecting data, but you have a small analytics team that's busy with other things, or data science team that wants to be worried about production problems instead of day-to-day analytics for the executive team. Or there might not be any data analytics team in-house at all. And with a tool like yours, they can be getting insights automatically without necessarily being able to write Python code.
Right. And I think even, so we started as a research project back at Stanford, where I was on the faculty, had a bunch of big tech companies sponsoring the work that we originally started. And it was surprising me where even, say, one of the largest online advertising companies in the world, which has amazing people optimizing click-through rate on ads, they don't have the headcount to put one analyst per account executive. The person who's managing the Nike account or the Adidas account, they're all going to have the same metrics, all different cuts of the data. They basically have a BI tool and a CRM, and it's entirely self-serve. So from a data science perspective, I like to think of it as you have all of this data. You basically have like zero recall in terms of useful information, unless you actually dig in on your own. And the ergonomics of those interfaces in terms of, entirely manually driven exploration, diagnosis, or if you're lucky to have a data scientist, bespoke regression models and then, R or scikit-learn to PowerPoint, which is a manual process. No one's written that compiler yet. It just doesn't scale, and not arguable what people are good at either. Right, the repetitive stuff is automatable and not perfectly, but again, if you're starting from zero, even incremental progress can radically improve on the state of the art.
You've mentioned a couple of times the idea of a slide deck, and it's interesting. When you first said that about compiling automatically to PowerPoint, we a lot of reports on my team, we have them compiled automatically to Excel so that I can send them to business people in the company. But you're right, I can't think of anything for PowerPoint specifically. But it's kind of beside the fact. What I was going to ask you is, because you've mentioned slide decks a couple of times, I'm guessing that there's also a visual aspect to the way that Sisu presents results.
Yeah, exactly. I think that's been one of the most interesting parts of our journey at Sisu, is realizing that analyst productivity, data science productivity is super, super important. But when you're in the cloud and you have a cloud warehouse, you don't have to worry about the intern taking down the data warehouse anymore, which was literally a concern. I interned at big internet company in 2012. Not me, fortunately, but another intern clogged up the Hadoop cluster. CEO didn't get their page view metrics at 6 a.m. for their report. So like you have everyone with access to this data. We've basically rewritten the data stack. You have better methods for pipelines, better ETL tools, better warehousing. I mean, data integration is still a pain and data prep still a pain, but it's like so much easier than ever before. But if you think about the number of people who have access to that data, if you can provide interfaces, which are basically low code or no code, so that they can actually make better use of that data, it's huge. And that's like kind of partly why we raised so much money, is that it is really hard to build out end user human in the loop data analytics pipelines, but the ROI for that is massive if you can go and reach those people, because they're the experts in the business, right? They are making the decisions. And if you can get the right data, the right people at the right time by continuously processing all of this and telling them things that they would otherwise have only caught retroactively, it's a really interesting value prop, and one that people find really compelling, because you're kind of sitting on top of all this data and you're stuck with a completely reactive manual analytics process.
Totally. We're at a point in the evolution of the data-driven enterprise that probably not most organizations in the West, but a large number of large cap companies have a lot of data that they collect. But there is still a huge gap between that and the problem that you're solving, where decision makers are in real time being able to themselves query these huge pools of data and get meaningful information that they can take action on right then and there. That's super cool. I love it. I feel like well, how can I send you money? Like, I want to invest. That's brilliant. I love it. All right, Peter. So a topic that you and I briefly touched on before we started recording was around how quickly evolving the data science and data analytics stack is today. So how does Sisu fit into that picture?
Right. I think if you look at a bunch of amazing products that have come out in the last several years, Snowflake, largest software IPO of all time, Databricks, chasing them, amazing productivity tools for data scientists. We've almost rewritten the entire stack in data up until kind of the business intelligence analytics layer. And that's almost been, there's a lot of great tools for doing the stuff we've done for the last 20 years. But, look, Tableau was originally called Polaris. The paper came out in 2002, right? It's 20-year-old technology, 20-year-old interface. And so our thesis is that last mile interface that most people have to access all this data is it needs to be rewritten for a world in which data is always arriving. You have way more context, way more features about the data, and everyone in the company has access to it. And that's kind of a huge problem. A lot of people have talked about data mining and insights and all stuff forever. But if you look at a typical organization, you mentioned kind of these big, large enterprises, it's not just tech companies that have this type of information now. It's like literally everyone. And the data is really well structured relative to what we would have seen 5 years ago, a bunch of files in a Hadoop cluster or on S3. It's like, it's pretty easy to go and get connected. And there's a lot of context and metadata and people who want to do more with this. And so the problem to solve is really at the end of the day a relevance problem, right? Like most people forget that in the early days of the internet, like there wasn't good measures of relevance. There's like, TF-IDF and the Yahoo Web Index, which is manually curated. Mm-hmm. And this type of data that's available inside of private enterprises is basically, data frames or tables, which tends to be very sparse, high dimensional, and pretty bespoke to each company. Mm-hmm. But just like today, where no one thinks, gosh, is my internet search query going to work because the internet got big enough and the ranking algorithms got good enough, there's a similar opportunity to actually improve ranking and relevance for all this private structured data in the cloud. And that's a super hard problem because you have way less supervision than you would in a public internet setting or in a consumer internet setting. Right. But again, when you're starting with a situation where you have zero recall, unless you manually click a button to slice and dice through a dashboard, and if you can calibrate your classifiers and your relevance routines, again, you can provide epsilon recall, and it's like a game changer for most people. And a lot of times there's a lot of statistical signal with fast-paced metrics like user engagement or conversion or margin that people just completely miss. And so the kind of goal in some sense for Sisu is to solve this relevance problem for structured data, which has really only been possible for the typical company in the last 5 years because of everything going on underneath the stack. And it's this analytics layer that's ready to get peeled off and radically improved.
Super cool. There were two terms that you used in there that I'd love to dig into more because I don't know what they mean very well. So yeah, I'd love to learn this, and I'm sure there's lots of audience members out there too. What's zero recall versus epsilon recall?
Oh, great. So look, when you have a classifier, you can have false positives, false negatives, right? And when you have low recall, when you have like zero recall, you're not getting any results, right? And in some sense, I say it has zero recall with a lot of analytics tools today because it's entirely incumbent on someone doing something, someone clicking a button to get anything useful about their data. And so if you can provide, like I say, epsilon, it's an infinitesimally small quantity. If you provide any like non-zero recall, it's super, super useful as long as you have reasonably high precision or you're telling people things they need to know. And I think it's just this interesting scenario where we tend to think about ML as need to be perfect before you ship it. This is a case where, provided you can calibrate your classifiers and ensure that you are finding some of those true positives and you're not showing people too much garbage, it's a really, really tractable kind of modeling process. And that's been surprisingly so, given how you'd think, okay, data in a consumer internet context versus data in a B2B SaaS engagement context versus fraud. I mean, there's just a lot of signal in this data people don't go and look at because, again, their interface requires them to do stuff in order to get results out of that. So that's what I mean by kind of providing non-zero recall because you can automate some of these things. And look, if you could tell people 5 things a week about their data and even 3 out of 5 or even 2 out of 5 of those are actionable and different and make them change what they're going to do on a day-to-day basis.
Yeah.
It's like unbelievable. And from a
Totally.
data science perspective, the metrics, you just define them once. The data is constantly changing. There's a set of procedures you want to run and rank and learn from users, and you can do a bunch of active learning, and it's much more tractable than you might imagine otherwise. And again, all the stuff underneath the stack has really enabled this.
An amazing answer and crystal clear, Peter. You took a complicated concept and broke it down in a way that was very easy for me to understand, and no doubt our listeners as well. In fact, you did it so well that it makes me think that you might have been an assistant professor at Stanford for 4 years. Oh, wait. Oh, yeah, you did do exactly that. So a question that I have for you is for people who come from the kind of academic, highly technical background that you have, do you have guidance for people looking to succeed in the commercial space? So now you're the founder and CEO of this high growth company. It isn't so uncommon for me to see people who come from technical undergrads or maybe even technical graduate backgrounds where they drop out of their PhD or they finish their PhD and they go and found a company. A lot of those people would become CTOs. But you went really deep with your academic background, 4 years as a faculty member at one of the top institutions in the world for technical applications of data science and computer science. And then you became founder and CEO of this high growth company. So yeah, I put a lot of context there. There's a lot of different places you could probably go from there, but generally, what guidance do you have for listeners to transition from an academic or technical background and have the kind of commercial success that you have?
It's a great question. And I think I'm still learning literally every day in this job. It's been a real education. I think 2 frameworks I found helpful in thinking about the transition from academia and the research community to, software startup, doing it for dollars, you name it. I think the first thing that's really underrated in academia is you actually do go and build a really useful toolkit no matter what space you're in, right? If you spend enough time grinding on problems, wandering through the wilderness, that is like choosing research problems or doing advanced, coursework, and you have to work on projects that are open-ended and so on, you're going to kind of pick up a set of tools, whether they're statistical or algorithmic or in terms of systems. And I like to think about it as CS in particular as a discipline, providing kind of this toolkit where you're going to bring it with you to go and solve problems. And in knowing what's in your toolkit and then also having a growth mindset to figure out what else you can pick up in your toolkit, super useful. A lot of it comes down to pattern recognition, right? I think for me, a lot of my research was less how do I come up with entirely new methods, but how do I take the methods that are the things that are supposed to work and make them work on messy data, define the right types of problems and make stuff really fast. So kind of speed, which helps a lot at the company because we process cloud scale data, and there's a lot of algorithmic challenges to make things run on for billions of features and billions of rows and so on. Just knowing your toolkit and building that toolkit, super, super useful. I think in academia, the second part of this, in academia, you get to kind of work on whatever you want, right? Like it's just, there's a space of interesting problems and you can kind of just go carve out whatever bit you want and work on. We worked on a bunch of really fun stuff. We worked with like people on doing earthquake monitoring. We looked at like fast algorithms for processing their time series. We worked with the big tech companies. We worked on stuff that no one cared about in terms of, I say no one cared about. There's some cool work someone will probably care about eventually, but it's kind of like you get to kind of like say someone's going to care about this problem eventually. It's a cool problem to go solve. And so I think the thing that you have to do when you go into like, the real world, quote unquote, is just be really diligent and thoughtful around who cares. And one of the things I find that's very challenging, but also super gratifying is there are certain metrics in a business that just tell you how well you're doing. And the 2 easiest ones, which are kind of North Star metrics, are revenue, right? Are people going to pay you hard-earned cash to solve the problems that you're solving, or internally, do they give you a resource to go to this? And then engagement, right? Are they actually engaging with the product? Are they getting value and so on? And so I think that in some sense, and what really pulled me into this role was this idea that I get to work on super hard problems. Over time, less and less of them incredibly technical, but you get very clear validation about whether or not the problems are meaningful and useful. And so if you can take your tool, putting this together, if you can take your toolkit of things you're really good at and things you've really developed your craft in, find a problem where people really have a lot of pain and you think you can make a dent, just iterating super fast with those folks. It's a little bit different. It's unlike writing a paper or getting a PhD where you're wandering through the wilderness defining problems. Here you're wandering through the wilderness trying to figure out where's the pain, what can I go solve for, and so on. But when you kind of find those two that collide, it's super interesting. And the company context, you're also doing as part of a team. I don't think academia is nearly as much of a team sport as people might expect. It's always who's the lead author, who's got credit on this, so on. Doing the company, you have 10 to 1,000 people just grinding on one thing with a bunch of different skill sets. So that you can take your toolkit and find people to amplify that toolkit and fill out other parts of the toolkit. And that's just like super, super gratifying. I think I underrated how valuable that would be kind of heading out of academia.
Yeah. On the last point that you made there, a brilliant friend of mine who is a listener of this podcast and who shall remain nameless, but who lives in Sydney, and I know you're listening, was an academic for a really long time and left because he was sick of being in meetings where people were fighting over their author order on the paper name. And he was like, this is not what I want to be doing with my life. And so found an amazing company to work at that lots of people would know, but I'm not going to mention, that allows him to still have this kind of academic feel, but way more teamwork, way more about, how can we be solving problems, like you're saying, how can we be finding pain points and executing on those? And so I love the frameworks that you provided. If I got this right, the first framework you provided for people making this transition from an academic background to tech startups was kind of awareness of your toolkit and then having a growth mindset beyond the tools you have. And the second one was figuring out who cares about what your business is doing and having revenue, engagement, and pain points as great places to look to see who might care about problems you could be solving. All right, so given all of the growth that you've had, I'm sure you've done a lot of hiring. Peter, what do you look for in the data scientists or the software engineers that you hire?
We do a lot of hiring. And it's funny because in our business, right, we're building something that combines a lot of different skill sets. So we have some pretty hardcore statistics and machine learning beyond just commercial off the shelf. We don't run a Spark package. We write basically all of our hypothesis testing, false discovery rate controls, all of the kind of core ML we basically write on our own because nothing scales to the size of data that we are processing for our customers. So it's all bespoke and usually has some tweaks that have to make it either run fast or just work in a robust way, in a way that, whatever stats paper, that came from, they probably didn't think about these issues. So we hire a bunch of people who have this kind of core statistics focus, but we have to run this on the cloud at really big scale and interactive speeds. Also have to hire people on the engineering side who are in basically, data parallel processing. So they've worked on databases, or they're really good at distributed systems, or they're just really good low-level systems hackers, like in networking or otherwise. And then there's a whole bunch to make this useful to users, right? It's human in the loop, and it's on these data sets that, unfortunately, there's no great, public corpuses of tables you can go do a bunch of research on, unlike, the internet where you can do unstructured data. It's really hard to get structured data because this is really, really valuable to customers. So you have to kind of combine this ML and data systems and kind of almost HCI bent. And it's really hard to get one person who can do all three of these. You're lucky if you get like two out of three.
Totally.
And that's kind of the fun part of the company. I actually, one of the reasons we started is I didn't think it would happen unless if we did it and brought people together around this kind of common goal. But as a result, when we hire, at least on the technical side, it's so important that we have people with that type of growth mindset where they are, let's say, hungry enough to like dig in, roll up sleeves, super excited about big, audacious projects, but also humble enough that they know they don't know all the answers. And we spend a lot of time working between product and design and ML and our core engine and our full stack engineering teams to really iterate quickly with customers. And that's something we just test for really, really kind of intentionally in our interview process. It's not just, is this person really, really good at one or possibly two of these different dimensions, but they also super hungry about going and building something special and something different and something new. And that's also honestly one of the reasons why people come here is, instead of going to Google Brain or choose your favorite, big tech companies that, they're not just building a better, faster, cheaper X, they're building something net new by coming together.
Nicely said. I love those answers. And some of them, like the humility aspect, I feel like I don't hear that enough. And for me personally, that also is such a huge thing on teams that I hire. So I love this all together: the growth mindset, humility, hunger, and having at least a couple of the core competencies that you're looking for, and knowing that it's very difficult to find people who have everything in one. But yeah, they can grow into it. Nice. So I expect that as your company's grown, you don't get to spend as much time as you might like actually rolling your sleeves up and writing code, but it was a big part of your past, and I'm sure you find ways to squeeze it in. So, are there particular software libraries that you love to still use today? And a second part of this question is, now that you're getting more and more into product development and management, maybe there's productivity tools or management tools that you'd also have to recommend to us.
Totally. I still think my favorite tool to use is, pen and paper or a whiteboard. One of the big things I miss, my wife has not let me get one, but one of the biggest things I miss.
Your wife hasn't let you get a pencil.
She's good with a pencil, but I like the huge whiteboards. I mean, there's nothing like a giant whiteboard to stand and go diagram something or work through some math. I really like just sitting down and be able to do that. I think that some of the new collaboration tools have gotten a lot better. So we just started doing some more of our remote kind of syncs through FigJam from Figma, which doesn't support LaTeX, but is still pretty good. And you can kind of read between the dollar signs and interpolate what the equation should say. I think we do a lot of prototyping with our customers. So tons of work with notebooks, and then also cheap ways to prototype those notebooks and put them to UIs and mocks. So it's kind of fun to take like Matplotlib output and then paste it into like a Figma mock that then you put in front of a user. But it's pretty compelling. You can literally see their data. So I guess I'm a big Figma fan, given how much product development we do, Figma and FigJam, and then just good old Jupyter notebooks and pen and paper. I think that on the management side, I think keeping a clean inbox is super hard. I think the biggest thing I just use is most just notepads. I use notepads like obsessively, just the text edit on my machine. And I used to freak out because I said, I'm going to drop all this different stuff. I'm not going to get it all done. But I realized if I can get like 3 or 4 things done a day that I really care about outside of the meetings and whatever's popping up, interviews, that's pretty good, right? So yeah. I just have these notepads I put on my desktop and then migrate them over to a folder, and they have like the most urgent stuff. And then if I drop stuff and it doesn't come back, then maybe I didn't need to do it in the first place.
That's great. I love that. Yeah, Peter, that is cool. I mean, for many years, I too was a big fan of the to-do lists in TextEdit on my Mac, and that jointly with a note on my phone. And now, I don't know, I've got all kinds of newfangled ways of keeping track of my to-do list, but does that really matter? It's still just a few words. So that makes a lot of sense to me. And I love the other recommendations around FigJam. That is actually one I'm not familiar with. We use Figma a bit at my company, but I'm going to look into FigJam. And yeah, pen and paper, hugely valuable, getting away from the screen and writing things out. I find you get a lot more clarity that way. And then whiteboards, I've got just off camera, tons of big whiteboards. I am allowed to have them in my house. So I'm sorry. But yeah,
I should probably ask, I've been afraid, I got in trouble at Stanford because we had these 14-foot ones we put in the office. We just measured how big the room was, and we want a whiteboard that big. So that's like my platonic ideal. It's not the painted on one. It's like you get a giant one, but you have to have multiple people carry it up and stuff. So that's like the ask I'm saving up for. I should see it. If my wife, Suma, if you're listening to this, then there's the ask.
We'll be sure to send her. We'll send her a special CD version, and then she can try to find a CD player in your home and play it. Yeah, I think the whiteboards are huge for me. Collaborating prior to the pandemic, that was the biggest thing that I was like, I don't know how I'm going to replicate this in the pandemic environment. For me, using whiteboards with my team, both for tracking what we have to deliver on today, in the coming weeks, and then just ideating on different things. So what I do, I've never had a 14-foot whiteboard, but I'll have a stack of whiteboards on one side of the room, and you kind of like shuffle through them for like today's to-dos. Okay, here's one that has some old stuff on it. We can erase that and ideate on like this problem that we're trying to solve together. And, I was unable to replicate that through the pandemic. There's just some kinds of R&D that we didn't do altogether. And I don't know. So I'm stoked that we're spending a bit of time now in the office. It sounds like you're today in the office.
We're inching back into it. It's funny that you mentioned not being able to replicate whiteboards. I still don't think it's replicable. We had a meeting earlier today talking about some prototype we're doing, and we were talking about how we should split up, our folds for doing some stuff around K-fold cross-validation. And there's some calibration we want to do with the models to go assess, can we let them abstain from making certain predictions? And it was just so easy to get on there with like a, you draw your folds in the data set. It's like, okay, well, this would be we could have a separate holdout set, or we could put this actually and split it from all these and then resample. And like, it's so much easier to visually, even saying it now, it feels so abstract versus, you just draw like, 6 boxes on the whiteboard and you're like, okay, great. This makes tons of sense. And I think that tangibility is tough. I'm kind of bullish. I hope the metaverse stuff works out. Maybe not from the Meta company, but from someone, because replicate some of that
from anybody else, please.
But I'm not holding my breath. But that there's something I think just from a thought process perspective, right? There's always this. I think Leslie Lamport had this amazing thing. As computer scientist, he said, if you think you have proven something, write it down. Or if you think you've proven something, if you think you have an idea, write it down. If you think the idea is right, try to prove it. If you think you've proven it, write it up in TLA and have a machine check it or whatever. Like there's some structure in a lot of these mental processes that actually helps with the thinking. I think something about being kinetically active and actually just going through the physical process of working through something with your body is a huge shift compared to just sitting down. In the same way that, writing up a paper or writing down a proposal or doing a 1-page PRM, there's something about the kind of act of doing that sharpens your mind and really focuses. And the more abstract the problems, the easier that I think that connection to, I sound crazy, but I think it's really, really something I've missed. Is that ability to be kinetic when you're thinking.
I agree 100%. And something that I've thought about a lot before, and I don't know if I've talked about it out loud, but I think that, I don't know if it's something to do with the generation that we're in, and you look like you're probably roughly my age. We probably, got the internet started to become a thing probably around the same time in our lives, and typing. But I grew up writing everything with paper and a pencil, and I don't know if it's because of that experience or if it's something about, I have a hypothesis that it's something to do with that only primarily using motor cortex on one side of my brain. That I am way more creative with my thinking when I'm writing as opposed to typing, which requires both hands. And so, like, you kind of describe that process there of when I'm trying to be creative, it's a lot easier for me to be writing on my notepad, to be coming up with ideas. So when we came up with the outline for this episode before we started recording, that isn't something I'm going to type up.
Right.
I'm like thinking, and it kind of helps me have like maybe more of my mind is available for kind of open field thinking. And so that's one thing. And the other thing that I wanted to touch on related to this whiteboard idea is that in some ways we could say, okay, everything that you guys have described, Peter and John on the show, I could very easily replicate this digitally. What a whiteboard does is very simple. You've got a whiteboard, and then you choose different colored markers and you draw them on a screen. So, okay, let's use like, a tablet or something so that we recreate that writing on the screen. And then you can share that with your team. We can do it over the internet, very easy. I'm sure there's hundreds of software tools that people have devised that do exactly just that and tons more. But the key thing that doesn't do is get me away from my computer, which a lot of the most innovative and helpful sessions that my data science team has had, I would call them a local science conference, where we'd okay, we got this big problem that somebody on the team is trying to tackle. We book a separate meeting room away from our usual room that doesn't have any screens, that doesn't have a whiteboard, and we can't bring our computers with us. And you just start from the beginning, and somebody draws, okay, here's the problem that I'm tackling. Here's where I'm getting stuck. And it might take them an hour to do that. But everybody's sitting there listening in a way that if they did that on their computer, even if everybody closed every other application on their computer, because you use your computer for so many different kinds of things, your mind can't help but think about, I wonder if I'm getting an email. Anyway.
No, I totally agree. I think that one of the amazing things about just turning off is also be able to turn back on. So especially in research, when you have kind of the rough problem you want to go solve, you think it's mostly solvable, but you don't quite have all the pieces. I remember we were working on some stuff trying to run related to Sisu, but not stuff we're using today. How do you learn models over streams? Right? There's all these streaming algorithms for doing counts and sums. How do you do it when you want to learn like a linear model or run gradient descent over a stream? And it was pretty close. We had some promising initial results in notebooks, like I said, and then it's like, what happens next? And I think when you find a good problem, it feels there's like this part of my brain that turns on. It almost is more on like getting ready for bed or making dinner or like in the shower. Like so many of the things we do in research end up being literally shower thoughts. And then you go back into the notebook or back into the prototype or back into the lab meetings. Like, hey, what about this? And I think that shift in modality is really fun. I think as a grad school at Berkeley, and Berkeley is amazing because they have so many different libraries on campus and you can easily walk between them. So I had this like rotation where I would go to the architecture library, then I would go to this cafe Strata, I think it was outdoors, then go to dinner and then on the south side, then go to the law library and then go to the stacks. And like, that was like my route. And then I would go for a run at like 11 p.m. It was like the best to have that rotation of places to think and just super, super fun. So I think that's like one thing I missed the most with kind of lockdown is just being able to have that mobility. And I think one of the nice things about actually being in a company versus being kind of an individual researcher or a smaller group of people, we had like a 10-person lab, is you can replicate some of that change in scenery by talking to different people.
Yeah, that's true. Absolutely.
So.
Yeah. Some people I talk to are a verdant forest, and others are a dark storm. Yeah. All right. So we managed to go quite a ways off piste here, but I really enjoyed this conversation about whiteboards and ideating, and hopefully some audience members out there did as well. I'm sure there were some people out there going, "Yeah, it's totally what it's like in my head." So we've touched on this a couple of times in the episode, and I'd love to dig into it more, which is your academic research as an assistant professor at Stanford. So, and I'm sure that followed on from what you were doing in your PhD at UC Berkeley, if I remember correctly.
Yep.
And so, so you have, this long history of tackling complex computer science problems. It sounds like some of those rolled into what you're doing at Sisu, but do you want to dig into it a little bit more? I'd love to hear about it.
Totally. So, I've always been in kind of data and making stuff fast. And when I took this job at Stanford back in 2015. I was going on the tenure track to give about 7 years to go and make it happen. And I previously been working on some kind of cool problems in data around making systems faster. So my thesis was specifically on what guarantees can you put on data if you don't allow databases to communicate? So you can be on opposite sides of the planet instead of being limited by the speed of light until we solve quantum entanglement. How can I go and just run operations independently? And what types of guarantees can I provide? And when do I need to synchronize? So a really simple example, if there's if we want to make sure there's only one person named Peter in the database, then if you on our opposite sides of the planet, we have to communicate. Otherwise, if we make sure that no one in the database is named Peter, suddenly we can guarantee that without synchronization. So what makes those properties different? Yada yada yada. Right. And it was a really fun thing. Wrote a bunch of fun papers. But when I started at Stanford, I said, well, look, the databases that we had built and a lot of other smarter people have built are so fast that you can basically run enough transactions per person on the planet, like one transaction per person on the planet every minute with like $500,000 of hardware. And so, like, unless if Amazon gets really, really, really popular, it's not a problem anymore. And took a step back and said, what am I spending 7 years on? And the broad theme, and I like working on these really hairy, poorly specified problems and carving out little bits to make incremental progress on, was in a world where data is effectively free to store, and I have as much compute as I want to scale out to answer any question, make any query run faster, where's the bottleneck lie? And even before starting at Stanford, spent some time with some friends who were at startups who were super smart technically, but were struggling with questions like, I've got a mobile application deployed. Some of my users have really poor engagement. Why? One of them was a smartphone application to tell you if you're driving well or not. Sometimes people were marked as really good drivers, just consistently. Why? Well, their models they were shipping every release. Some of them didn't work well with some of different Android devices. So you were either you considered a great driver because you bought a crappy phone, or a bad driver because your phone accelerometer was not behaving well. So started to see this problem crop up again. I gave myself 2 years actually to see if I could write papers in this space. And the general flavor of thing we started working on were kind of two key themes. One was a lot of the techniques required to go and in some sense prioritize people's attention in these large scale data sets. There's really good statistical methods for going and solving a lot of problems if you map a problem down to these methods. So for example, I want to find unusual points. Great. Density estimation. What's the best non-parametric density estimator? Kernel density estimation. Great. So that's like a primitive we can go use. We started treating stats methods as primitives. But then the question was, how do you compose these primitives? And then how do you make them run very fast? And as soon as you start looking at end-to-end pipelines of these operators, there's a huge amount of optimization opportunities that you don't look at in isolation. And in turn, you can turn into software systems that go and self-optimize in some sense. So concrete example, one of the first papers we wrote was this paper, Accelerating Kernel Density Estimation, which is an n-squared operation, scales really poorly over even modestly sized data sets. And we realized that if you just want to find these unusual data points, you just have to refine an estimate until you're very clearly in a normal region or in a abnormal region. And you can actually stop your estimate of the kernel density estimate really early, depending on the region that you're in.
So even though there's this polynomial time complexity, this n-squared time complexity for the computations, you're able to, in a lot of circumstances, stop early.
Exactly, because you know that you only want to know binary bit. Are you in a dense region or a sparse region? And once you know for sure, because your error bars are above the cut or below the cut, you're done. And you can prove that it's end of the 7/8 or end of the something like a small asymptotic improvement. You can prove that, but also just in real time made these things that were not tractable over the data sets we were looking at way, way, way faster. And we did a lot of work in that flavor, and also worked on some really crazy problems as well. So for example, we use this at Sisu, but now Datadog uses it and Timescale DB and so on. This is where I started doing this human in the loop stuff. One of the problems we worked on was a lot of people when they're looking at time series data and let's say I find some spike looks weird, or I find some time series signature that's problematic, they just plot the raw data in the time series. And if you zoom out and you have periodicity in your data, it's super noisy, right? It's really hard. It just looks like a bunch of spikes. And so we worked on this really hairy problem of saying, what does it mean to choose an optimal window to smooth your data? And we actually came up with a policy around preserving kind of the skewness of the data set and then minimizing the variance across the plots. And then it turned out it's really slow again, another n-squared problem to go and compute the optimal whatever. So then we made that really fast. And then we made a JavaScript library, and a bunch of people use this now to smooth their visualizations. And it was funny. This is one of the first inklings I had that maybe doing this for real would be more fun than doing it in the lab, because we had a massive user study of 750 people on Mechanical Turk trying to pick out here's a plot of taxi volume in New York. In what month did the volume drop? And you'd have this blind study where you'd show people the unsmooth thing. You'd show them a bunch of alternative smooths. You'd show what we did with this algorithm called ASAP. And it was like, why can't we just show this for real users? And we were lucky because we had some good intuition, and that's why folks like Datadog have put this in their products. But it's just fun to basically say, what's like the right thing to do? What are the right statistical measures? How do you make them fast? How do you make them usable? And we ended up putting all this together inside of basically software we gave away for free. People started picking it up. And at a certain point, I realized we can make this work for a bunch of big tech companies. We had 20,000 public information. We had 20,000 queries a week on this backend we stood up at Microsoft, and written papers at Google and Facebook about some of the work we did there. But it was like you said at the start of the episode, it's like everyone has this type of data now. Like in 2015, Snowflake was not a huge thing, right? It was just getting bigger. But by the time it was 2018, it was clear that more people would have this type of data, and we could do these types of optimizations and end-to-end, usable machine learning for like people who weren't just in tech. And again, it's like standing on the sidelines and like some of the stuff seems not obvious, but like it should be built. So why isn't it being built? And I think it comes back to, again, how we hire. It's knowing the right statistics, having the right taste. It's knowing how to make them run really, really, really fast. And then it's making them useful to people who, would never write these pipelines in the first place, but would hugely benefit from them.
Nice. So if I can try to summarize all of what you just eloquently said in like a phrase, it might be that kind of a big focus of yours, something that I picked up on a couple of times there, is taking processes that if you were to run them kind of in the naive implementation comprehensively, they'd be this polynomial time complexity, this n squared time complexity that, in practice for, getting real-time information from some process is impractical. And so you come up with some tricks, some ways of going from that really, intractable time complexity to something that's fast, something that's instantaneous. And then you present that to your users. And so that was a problem that you've been tackling for a long time. And you realize there's this opportunity to go from paying people a few dollars an hour in a Mechanical Turk to be looking at these kinds of results, to having it the other way around, having an even bigger number of people paying you to see their data in real time and make that a commercial application.
Absolutely. And I think that the key thing I'd say is it's not just, these are in some sense tricks, right? It's algorithmic techniques, and it's different.
Right. Yeah.
Approaches.
It's not magic. No magic. No.
Well, the key thing is that if you just look at these kernels basically in isolation, right, they're super well optimized, right? But if you look at what people at the end result, the people who are going to be consuming this information, and you look at it as a full pipeline, there's a huge number of kind of algorithmic and systems things in my toolkit that I know I can make this work. And then by working with great product people, you can actually make it intuitive. Some stuff that's dirt simple once you look at it. But for example, for this ASAP algorithm I mentioned for the smoothing, you can avoid, if you have, let's say 800 pixels to show a graph and you have a billion data points, most window sizes yield the same visualization when you're looking at 800 pixels. Mm-hmm. So you can downsample your data appropriately before you start running some of the expensive search procedures. And again, there's kind of this set of tricks that we learn to apply even automatically, and then build up interfaces around them. So it's not that the tricks and speed ups are independent of the interfaces because they're enabled by it. It's like looking at the end-to-end pipeline. And I think a lot of work in ML and data science, I think, is often in the context of just an ML or data science workflow. And we talk about that, compiling the slides. Like if you actually think about what needs to go in that slide, what people need to see, suddenly that gives you a lot more degrees of freedom in terms of the choices of models you use, but in a lot of ways helps you restrict the optimization space quite a bit, because you don't have to go and compute over a lot of the data that if you just said, hey, give me this estimate or give me this model or give me this thing, like in a vacuum, it just wouldn't make sense. And that's, again, coming back to working on problems that are useful to people and, interesting, and that problems that are useful to people give you constraints, and the constraints allow you to optimize.
Awesome. Well, that's super interesting, and I would love to take all day with you and ask you more and more questions. But you've got a big, fast-growing company to run, so I'm gonna leave it there. We're gonna cut to the question that I ask all of our guests at the end of the show, which is, do you have a book recommendation for us?
Somewhat unrelated to the stuff we've talked about so far. I think especially with a lot of the debate over, again, metaverse and NFTs and authenticity, I've been reading a pretty interesting book by one of the best wine importers in the Bay Area. I'm not a wine snob, but a friend told me about this book. This guy, Kermit Lynch, who was one of the first people to really dig into importing great wine, touches on, it's 25 years old, so it's like from a different era, which is amazing. The era when we're buying Bored Apes on OpenSea, right? It feels completely divorced from that kind of, talk about getting away from the computer. But it's also interesting to think about how they approach things like authenticity and certification of physical assets in a kind of not quite pre-digital world, but like metaverse world, let's say.
Right.
So it's been fun to like read that and then also compare it to what's going on in the media and where future work may be heading and all these sort of things. And just wondering, what happens for the future of our, physical assets and how do we think about them, so on. So maybe provoking 1988, I'd recommend it.
Right. Yeah. I'm not a wine snob. I'm doing this to learn more about technology.
Exactly.
Great. I love that book recommendation. So, Peter, you're clearly brilliant. I've learned tons from you in this episode. I'm sure lots of our audience members have as well. Do you have? How should people follow you? What's your social medium of choice?
I'm mostly on Twitter at Bailis, and increasingly, as my role as CEO, I'm on LinkedIn as well. So sometimes I write blogs on our CC Data blog. I kind of have an agreement with our marketing team that if anything I kind of sit down and spend more than 2 hours writing, they'll put it up on the blog. So there's sometimes interesting content there.
Nice. All right. Well, I'll make sure we have all three of those in the show notes. Your LinkedIn, your Twitter. Actually, not in that order. Let's do the other order since you Twitter first, then LinkedIn, and then the Sisu blog. Brilliant, Peter. Thank you so much for taking the time to be on the show, and hopefully we can have you on again sometime.
Thank you so much. It's been a real pleasure.
Holy crap, what a remarkable person Peter is. I love how he's so clearly wildly intelligent, but nevertheless so grounded and easy to relate to. In today's episode, Peter filled us in on how a decision intelligence engine like Sisu Data's enables decision makers in a company to have immediate access to the causal factors behind their critical business metrics. He talked about his two frameworks for succeeding at growing a tech startup, namely knowing your toolkit and having a growth mindset to expand it, and secondly, having a clear idea of who cares about your business from either a revenue, engagement, or pain point perspective. He talked about what he looks for most in the folks that he hires, including humility, hunger, and expertise in statistics and computer science. And he talked about his favorite productivity tools, including classics like a good old physical whiteboard or pen and paper, as well as new digital tools like TextEdit, Jupyter Notebooks, and the FigJam digital whiteboarding tool by Figma. As always, you can get all the show notes, including the transcript for this episode, the video recording, any materials mentioned on the show, the URLs for Peter's Twitter, LinkedIn, and company blog, as well as my own social media profiles at superdatascience.com/527. That's www.superdatascience.com/527. If you enjoyed this episode, I'd greatly appreciate it if you left a review on your favorite podcasting app or on the Super Data Science YouTube channel. I also encourage you to let me know your thoughts on this episode directly by adding me on LinkedIn or Twitter and then tagging me in a post about it. Your feedback is invaluable for helping us shape future episodes of the show. All right. Thanks to Ivana, Mario, Jaime, JP, and Kirill on the Super Data Science team for managing and producing another fun and informative episode for us today. Keep on rocking it out there, folks, and I'm looking forward to enjoying another round of the Super Data Science podcast with you very soon.